This is our Redox ChemCast. Okay, so the first problem is to identify the oxidizing agent, reducing agent, and to find what is being oxidized and reduced. This is similar to number 55A on page 859. Remember that oxidation means the loss of electrons, while reduction means the gain of electrons. So the first step is to assign oxidation numbers to all atoms. So in this equation, the oxidation numbers are 0, 0, plus 3, and minus 1. Step 2 is to identify what is being oxidized and reduced. Gallium is being oxidized because it has lost 3 electrons, going from an oxidation number of 0 to plus 3. Bromine has been reduced because it has gained 1 electron. This equation looks like you can just balance it by changing the coefficients, but you actually need to balance the electrons. Step 3 is to determine the change in oxidation number. So for the first half reaction, gallium has lost 3 electrons. And for the second half reaction, bromine has gained 2 electrons. While the oxidation number of bromine has gone from 0 to minus 1, since there are 2 bromine atoms, the overall change is 2 electrons. For step 4, you need to adjust the coefficients. Note that in order for the equation to make sense, electrons transferred must be equal. So we are going to multiply the first equation by 2 and the second equation by 3. So after multiplying, this is our final answer.
Okay, so this is our second problem. To identify the oxidizing agent, reducing agent, what is being oxidized and what is being reduced. Step 1, like in the previous problem, is to assign oxidation numbers to all atoms. So this is 0, minus 2 for oxygen, plus 5 for nitrogen, plus 2, minus 2, and plus 2. Now step 2 is to identify what is being oxidized and what is being reduced. So copper is oxidized because its oxidation number is increased, and nitrogen is reduced because its oxidation number decreases. Step 3 is to determine the change in oxidation number. So these are our half reactions. And copper goes from 0 to plus 2, so we have a transfer of 2 electrons. And this is a change of 3 electrons. Step 4 is to adjust coefficients and balance the particles. So because we have oxygens in the nitrogen particle, the NO has 1 oxygen, the nitrite particle has 3 oxygens, so we're going to add 2 H2O particles on this side. So now we have 2 oxygens here, so the oxygens are balanced. So now we have to balance the hydrogen particles, so we add 4H plus on this side. Now that all the particles are balanced, we're going to adjust the coefficients to so that the electrons transferred are equal. So we're going to multiply the top by 3 and the bottom by 2. And our final answer, this. That. Okay.
And here's a famous real-world application of the redox reaction. A space shuttle gains nearly 72% of its lift from its solid rocket boosters during the first 2 minutes of launch. The rocket is fueled by the explosive mixture of ammonium perchlorate and aluminum. The balanced equation for the reaction is shown here.
And that's our project.